Hello, my name is Jared Skeens and welcome to Quick Fix. Today we want to look at the IGCSE paper 2. Let me pull it up for you. For the October-November 2018 IGCSE series. And this is the paper 2. I've already made a video and uploaded to YouTube for the paper 4 if you're interested in that one as well. So let's get started. It's an hour-and-a-half test. I've already made the solutions and just want to walk through the thinking involved with these questions. So first here, we have standard form. Now remember, standard form has a rule. You can only have one number in front of the decimal point. A lot of students forget this and they ended up putting like 23 times 10 to the third or something like that. So it's important to remember you're only allowed one number in front of the decimal. So you start here at the end of the number is where your decimal is located, and you move it over 1, 2, 3, 4 spaces so that only the 2 is in front of it, and you should get 2.3 times 10 to the fourth. Then here is geometric properties of circles involving chords. It says that O is the center, A, B, and D, E are both chords of the circle, and M is the midpoint of AB, and N is the midpoint of DE. Now the significance of it being the midpoint means that from the origin to the midpoint creates a 90-degree angle. There is important. It also states that AB and DE are both 9 centimeters, meaning that these chords are the same length. So if they're both the same length, and if M and N are both the midpoints, then the length from O to M and the length from O to N have to also be the same length. So since OM is 5, then that means ON is 5 also. Moving on, we have calculate 0.125 to the negative, I think that's a negative 2/3 power. It's a little kind of blurry there. And you get 4. This is just a calculator exercise, so make sure that you're plugging it into your calculator correctly, and you should end up with 4. If you don't end up with 4, then you should ask a friend or someone to help you learn how to type that into your calculator. Moving on to number 4, simple algebraic expansion. Remember that multiplication distributes over addition and subtraction. So 2x times 3 is 6x. 2x times a negative x squared is a negative 2x cubed. Remember, you're adding exponents. The basic math is just 2 times negative 1. And then your algebra rule is to add the exponents. So 1 plus 2 is 3. So just be careful that you're doing it accurately. 6x minus 2x cubed. And then we have fractions, adding and subtracting fractions without your calculator. And this is just common denominator. So common denominator between 15 and 5 is 15. This 15 is already there. Doesn't need to do anything with that. And here we have a 5, so it needs multiplied by 3. Whatever you do to the bottom, you do to the top. And so you end up with 6/15. Now that you have a common denominator, you can unify your denominator, but you still need to add the numerator. 1 plus 6 is 7. No, you do not add the denominators. It's already a common denominator, and that just stays the same, so you get 7/15. Now we have this, and sorry that it's a little blurry. It's 7m minus 2 greater than or equal to 19. So we add 2 to both sides, get 7m greater than or equal to 21. Divide both sides by 7. M is greater than or equal to 3. You do not flip your inequality unless you multiply or divide by a negative. Then you would flip your inequality. So since we are not dividing by a negative, the inequality stays the same. So m greater than or equal to 3. Here we have elements. C are the elements of X that are between and not including 5 and 12. So I've written them here. They're integers, so they're integer elements where X is between but not including the 5 and the 12. So that would be 6, 7, 8, 9, 10, and 11, where the elements of D are just 5 and 10. So put a ring around the correct statement from the list below. So this one says that D is a null set. Well, obviously D is not a null set, it has 2 elements in it, so that's not it. This one over here says that 6 is an element of D. Oh no, 6 is not an element of D. And this one over here says that D is a subset of C. And while the 10 is in C, the 5 is not. So D is not a subset of C. This one says that the intersection of C and D, I know it's hard to see there, but that's the intersection of C and D is 10. And yes, we can see that when this set is intersected with this set, the 10 is the intersection when you put these 2 sets together. So this is the correct one. C, the intersection of C and D is the element 10. This one says find, and this is the union of C and D, the union of C and D, and there's a little N out here. That means the number, how many, not what are they, not to list them, but just how many. The little N means the number of when you join C and D together. So here we have 6, 7, 8, 9, 10, and 11. There's 6 items there. We already have the 10 included, and so we need the 5. So these 6 plus the 5 give us a total of 7 elements when you join together C and D. So 7 is the number. Moving down here says to factorize xy plus 5y plus 2x plus 10. So what do you want to do when you have 4 terms? Is you want to split it in half and factor both sides. As long as the factor that you get is identical on both sides, then you're doing it right. Sometimes you have to rearrange these items, but usually you can just split it in half. Notice to these 2, the y is common. So you factor out the y, that leaves you x plus 5 inside the parentheses. On this side, the 2 is common. And when you factor out the 2, remember factoring is dividing. So when you divide out the 2, you get x plus 5. So the key here is that this factor x plus 5 is identical to this one. If only the sign is different, you can factor out the sign, isn't a problem, can handle that. But these should be identical. So you have 2 sequential factorings. Now you want to factor again. The x plus 5 is what's common. You factor it out, divide it out, and you're left with the y plus 2, which is your answer. X plus 5 times y plus 2. And this just is factoring by grouping. Now we come down here to there's 30,000 lions in Africa. The number of lions in Africa decreases exponentially by 2% each year. So you're going to use basically the same formula that you use for compound interest is your exponential formula. So find the number of lions in Africa after 6 years, meaning we're finding our amount after time. And then give your answer correct to the nearest 100. So we start off, this is for your original amount, was 30,000 lions. These lions are decreasing from our original 100%, and they're decreasing by 2%. Make sure you enter it as a decimal, 0.02, and the time is 6 years. That's the exponent part. This you just plug in directly into your calculator, and your amount after time is 26,575. This asks us to make it correct to the nearest 100, which is this location right here. The number after it is 7, so it rounds up to 26,600. Moving on, here we ask us, in question 10 asks us to find the midpoint of A and B. Well, midpoint, you just add them together and divide by 2. So you add the x components together, w plus 3w, and then divide by 2 to find the middle, and r plus t divided by 2. So on the left here, the x, what would be the x coordinate, simplifies to 4w divided by 2, which is 2w. The right side, which would be the y component, is already as simplified as it gets. So you end up with 2w and r plus t divided by 2 as your midpoints of AB. Number 11 gives you an equilateral triangle of lengths, each side has lengths of 12 to the nearest centimeter. Find the lower bound and the upper bound of the perimeter of the triangle. Well, your perimeter of an equilateral triangle is just going to be 3 times s because all the sides are the same length. So just multiply it times 3. So for the lower bound, in these upper and lower bound problems, you have 2 layers that you're working with. The first layer is the layer of the value of your, your estimated value. This was your measured value is a side that is measured to be 12 to the nearest centimeter. So your first layer is finding your upper and lower bound. So meaning the lower bound is 11.5. So every number above 11.5 will round up to 12. If it's below 11.5, it would actually round down to 11. So 11.5 rounds up to 12. And then to find the upper boundary, we still take 12.5, even though technically the 12.5 is not included, it is the boundary. So in other words, 12.499999 needs to be included. So we just go ahead and put 12.5. If you looked at a domain statement, it would say that x is less than 12.5, but greater than and including the 11.5. Some students get a little confused why the 5 is included here. Technically, it's not included, but it is the boundary that includes your 12.4999999. So the 12.5 is the boundary, although technically it's not included in the domain statement. So that's your first layer, is simply doing 0.5 because it's to the nearest centimeter, above and below are 12. Then the second layer deals with the formula itself, and we want to get the maximum or minimum bound for the formula. So this is our second layer that we deal with. So our perimeter for the lower bound is of course going to use the lower value. So 3 times 11.5 is 34.5. That is our lower bound for the perimeter. Then the upper bound for the perimeter is using the higher value. 3 times 12.5 gives you an upper bound of 37.5 centimeters. So meaning if you have an equilateral triangle where you have measured out 12, accurate to the nearest centimeter, it might not be exactly 12 centimeters. It's rounded or measured accurate to the nearest centimeter, which would be 12. So the actual perimeter could be anywhere from 34.5 to 37.5 instead of just adding 12 plus 12 plus 12, which is 36. 36 is what it would be mathematically by the number of 12, but because this is a measured value, then the actual perimeter could have a range, 34.5 to 37.5. So you got your 2 layers here. The first layer deals with your measured value. Your second layer deals with how to maximize or minimize the formula, and that gives you your upper and lower bounds. Moving on, here we have an obtuse angle. So when you solve for x, you still inverse sine your 0.43. And notice you're in degrees, so make sure your calculator is in degree mode when you do this, because you're using a trig function on your calculator. And your x degree would be 25.47 is what the calculator gives you, because your calculator gives you the acute angle. So in order to obtain obtuse, remember your sign is positive in both the first and second quadrants. So the 25.47 would be your acute angle in the first quadrant. To get the second quadrant angle, the obtuse angle, you just subtract it from 180, and that gives you 154.5. That's the obtuse angle. And if you want to double check it, just take sine of 25.47, it will give you your 0.43. And if you take sine of 154.5, it will also give you 0.43. So you can double check it if you want. Here we have a sequence, the first 5 terms of a sequence, -4, 2, 8, 14, and 20. This one's rather simple. You can see that it's just adding 6 to each one. This asks for an expression for the nth term. So your formula for that, your a to the nth, your nth term is your first term, which is -4, plus n minus 1 times the difference. The difference can either be positive or negative, because this is an arithmetic sequence, and so your difference is a +6. If it were a minus, make sure you're multiplying it by a -6. Okay, so this is increasing by 6. You just distribute the 6, simplify. So your nth term has the formula then as being 6n minus 10. Moving on, here we have linear equations, linear inequalities, and remember it wants you to shade the unwanted region. This can be confusing because usually in the textbooks ask you to shade the wanted region. You usually shade the solution set. So that's why this is bold. Remember that you are going opposite of the inequality when you're shading. So here we have a vertical line, x less than or equal to 3. So here is our vertical line crossing the x-axis at 3. Less than would be to the left. We want the unwanted part, so we shade to the right. Okay, so that right part's shaded. Then we have x greater than 2. Again, it's a vertical line crossing the x-axis at 2, which is this line right here. And this says greater than, which would be the right-hand side. So the unwanted part is the left-hand side. So we shade to the left of this line, x equals 2. Then we have this line here, y less than 2x plus 1. You should recognize that as this line here. Why is that this line here? Because it crosses the y-axis. This is y equals mx plus c. The y-intercept is at 1. The slope is 2, meaning up to over 1, you get back to the line. Not to mention it's positive slope, so it's going up. And so that is the line, and it says less than would be what you want. So the unwanted is greater than or above the line. So all you have to do is put your pencil anywhere along the line and go above is the not wanted. That's the left-hand side. So I have the shading going off at an angle perpendicular to my line all the way through the graph. Make sure you continue all the way through. Don't just do part of it. Go the entire length of the line and do shading perpendicular to it so that you can make sure you're getting all these areas shaded that need to be. Then you have y greater than or equal to 4 minus x. That is this line right here. Y, now it's switched around, so if you put it in slope-intercept form, it would be a negative 1x plus 4. So the plus 4 is our y-intercept up here with a slope of negative 1 down 1 over 1. So that's this line going right here. It says greater than, so the unwanted is less than. So again, go with your pencil anywhere on the line and just go below your graph. So I'm shading again at a perpendicular to my graph all the way through. the graph set here. So that only leaves one section that is not shaded. That is our solution set that satisfies all of these linear inequalities. Notice it says to label the region R. I noticed that some students forget to label the region R, the solution set. So in this case, the non-shaded section that's left over. So that's our solution there. Moving on to matrices. Now, this is from winter 18. So this is from the old syllabus. The new syllabus actually says that they are getting rid of matrices. So because this is now 2020, I haven't actually seen a new test paper except for the specimen paper. So hopefully these do not show up anymore in the future tests because the syllabus said that matrices is going to be taken out of the new syllabus. But just in case, these are actually pretty easy. This is a scalar 3 multiplying by your matrix. So you just multiply 3 into all the elements and you get 15, negative 9, negative 3, 6. This is asking for the inverse. So to do the inverse, you do the cross multiplying down, 5 times 2 minus the cross multiply up. So down minus up. So 2 times 5 is 10. Minus negative 1 times negative 3 is a positive 3. So 10 minus the 3 equals 7. And you put that 1 over what is called the determinant. What I just did was the determinant. The down minus up is the determinant. So 1 over the determinant, 1 over 7. You can leave it on the outside because in the Cambridge mark scheme, they give you 1 point for the number out here and then 1 point for the correct values in here. So if you distribute it through, it's okay as well, but you don't have to. So 1 over the determinant, 1 over 7 goes on the outside. Then you need to rearrange the 5 and 2, just simply need to switch places. So for this down cross here, diagonal down, you just switch the location of the 5 and 2, or some might call it the A, B, C, D. So your A and D switch places. And then the B and C stay in the same place, but you change the sign. So this becomes positive 3 and negative 1. So that's how you do an inverse matrix. If you wanted to double check it, you could, but this is only 2 points. You don't really need to. If you distribute the 1/7 through and then multiply this resulting matrix, inverse matrix by the original, you would get an identity matrix, which is 1, 0, 0, 1. So if you wanted to double check, you could, but you don't really need to. Down here, number 16, we have find the value of A and the value of B. We have A on one side, which is a quadratic already in standard form. We have B on the other side, which is in the square form. So if we square out the right-hand side, remember squares, exponents do not distribute to add and subtract. So you actually have to take x plus b times x plus b and then use like FOIL or smiley face method. So x times x is x squared, b times b is b squared, bx and another bx is 2bx. Then what we're doing is called, we're looking for the coefficients of the same exponent. So notice x squared and exponent here, x squared and x squared. I'm forgetting the name here of what this is called, but you look at x squared, that's the same. So equating coefficients, that's what we're doing. We're equating coefficients. So here's our x and here is our x. So that means the 2b has to be equal to the negative 12. 2b is equal to the negative 12. Divide by 2, b is negative 6. And then our a has to be equal, the constant on this side has to be equal to the constant on this side. So our a is equal to the b squared. Once we get b, we can plug it in up here. So a equals a negative 6 squared, which is positive 36. So you show good work. Make sure that you show your work so that people can understand what you're doing. So 36 and negative 6 is your answer for that. Now we come down here and it gives us this line. This is like coordinate geometry. with our C and D, the points at either end. -1, 2 is the point C, 9, 7 is the point D. It says that find the equation of the line perpendicular to CD. Now be very careful because sometimes they ask for the perpendicular bisector. This is not asking for the perpendicular bisector. The perpendicular bisector, you would have to find the midpoint. In fact, when I first worked this out, you see this empty space here, I actually found the midpoint, and then I realized I didn't need it because it's not asking for the perpendicular bisector. So be careful to read it. It's only asking for perpendicular, and it gives you a point that it goes through, and it's not the midpoint. So perpendicular means we need to find the slope of CD. So the slope of CD is y2 minus y1. So 7 minus 2 divided by x2 minus x1. So this is your change in y over change in x. 7 minus 2 is 5. 9 minus a -1 is 10, because the two negatives make it plus. Make sure you're going in the same direction. So this y minus this one means I have to take this x minus this one. Doesn't really matter which direction you go as long as you go the same direction with both elements. So 5/10 becomes 1/2. Perpendicular means you do the negative reciprocal. So we change the sign and flip it over. So it becomes a -2. Plug that into our slope-intercept form. So y equals a -2x plus c. Then we use the point to find the plus c. 3 is the y value, 1 is the x value. So here we have a -2, add it to the other side, gives us c equals 5. And then don't forget to write out the equation of the line combining your parts here, the slope and the y-intercept. So y equals a -2x plus 5. Moving on here, we have question number 18. We have 120 students. Choose what they want to do when they leave school, probably high school. Their choices are shown in the table. 57 out of these 120 students want to go to university. 45 of them want to go into some sort of a training program, and 18 of them just want to go directly into the workforce. So if you divide them here, you get your percentages. If you're making it into a pie chart, well, a pie chart is a circle, so you might want to take it and take the percent times 360. Sorry, I didn't show that work, but 40.475 times 360 degrees gives you 171 degrees. 0.375 times 360 gives you 135 degrees. And this here is 15% of 360 gives you 54 degrees. So you can use your little protractor to measure out the degrees here. And so here's 135, 54, and 171 degrees. Labeled it with university, training, and work. I also put in the percentages just so that it's clear which one is which. And that was just doing a pie chart. Moving on, we have this Pentagon diagram with A, B, C, D, E. And it asks us to use, it wants us to do a construction. Now, I'm not sure if constructions will be carried on into the 2020 syllabus or not. It didn't seem very clear. I should probably look at the syllabus again, but constructions aren't really that difficult. I think they left it out of the 2020 syllabus. I actually kind of like them, but anyway, in case they still are in the 2020 syllabus, it says construct a bisector of angle BCD. So to do an angle bisector, you put the point of your compass on the vertex of the angle, and you just open up your compass to a comfortable space. It shouldn't be too short that it's too close together, and obviously it can't be longer than this line CB. So whatever there's a comfortable space, then just mark a little tick mark here and swing it over to this other one and mark a tick mark there. Then you want to move your pointed part over to those tick marks And I like to just open it up a little bit more than what this was here. And so with your pointy part on this tick mark, then you make a mark somewhere of what you think is the middle of this angle. And then you put the pointy part over here on this tick mark, and you make an arc this way. And where those two intersect is where you want to draw your line from the vertex of this angle through that intersection, and that is your bisector for this angle. Then the next one says, draw the locus of points inside the pentagon that are 3 centimeters from E. So all the points equidistant from one point makes a circle, but you don't need to draw the entire circle. You just need to open your compass up to 3 centimeters in length, because it asked for 3 centimeters. Put the pointy part at E, which is going to be our center, and then just rotate that 3 centimeters in a circular arc. But you do not have to go all the way around E, because it just says in the pentagon. So you just have this partial sector here, the sector of a circle. And then it says to shade the region inside the pentagon that is, and notice this and statement. This and statement means both have to be true. So it's not either or, it's what parts or what points, locations satisfy both of these. So it needs to be less than 3 centimeters from E, so that's going to be inside the circle, and it needs to be nearer to DC than to BC. Now when you see this, nearer to DC than to BC, what it's doing is it's relating to your angle bisector that you just did. Notice your angle bisector cuts halfway in between the BC line and the DC line. So this is going to be your left and right. On this side of the line is closer to DC, and on this side of the line is closer to BC. So we want to be inside the circle. It said less than 3 centimeters from E. So it's going to be inside the circle, and at the same time, it has to be closer than the DC, which means to the left of this dividing line here. So that's only this part right here. Do not shade this part of the circle, and do not shade this part out here. It's only this part in here that should be shaded for that. And that's constructions. Then moving on here to question number 20. Make M the subject of the formula. So we have a fraction. We want to make this, we want to get rid of that fraction. So we multiply both sides by 2 minus M, and we distribute the x. So we get 2x minus mx. Now notice there are 2 terms that have M in the terms. So we need to get those on the same side. We need to get all the terms with M, which what we want to make the subject. We want to get all of those together, and any term that does not have an M in it, we move to the other side. So the 2x is already here, so we'll just add the mx to the other side. So notice all the terms without an M is over here, and all the terms with an M is over here. Now that we have those together, we can factor the M out. Remember, factoring is dividing, so we get 3 plus x is what's left. And to make M the subject means the M has to be by itself, and it's multiplying this 3 plus x, so we're going to divide both sides by 3 plus x, cancels over here, leaving us with the M. I put it in front because we want it to be the subject. Divide the 2x by 3 plus x. This does not simplify. Do not cancel the x's. This is a multiplication. This is an addition. Division does not undo addition. So be careful that you do not cancel unnecessarily. And so we get 2x over 3 plus x. Now here we have a little bit of sector geometry stuff going on here. We have an equilateral triangle. So here we have 10 down here, meaning all of them are 10 since it's equilateral. And we have a sector of a circle with center A. So this is a arc length here. And it says work out the area of the shaded region. The shaded region is this part right here. And of course, we don't have a geometric formula for this weird shape here. But we do have formulas for triangles and for sector area. So the area of a triangle, now I could have done 1/2 base times height. I could have divided this by 2 and done 5 and 10 and did the Pythagorean theorem to find the height. But I wanted to take the opportunity to show you that triangles also have a trigonometric formula, especially since this is equilateral. We know that the angles are all 60 degrees, and because it's equilateral, we also know all the sides. So if you want to find a quick way sometimes of the area of a triangle, it's 1/2 AB sine C, where A and B are the two sides and sine of C being the angle in between the two sides that you have. So it can actually come from any one of these sides. I actually did it from over here. I put my 60 degrees and I used this 10 and this 10, but it doesn't matter. So 1/2 times AB, which is 10 times 10, and sine of the angle in between, which is 60. And when you do this on your calculator, again, make sure you're in degree mode because you're using a trig function on your calculator, you get 43.3. And the area of your sector of a circle, since we're using degrees, we need to take the 60 out of 360. So it's the fraction of the circle that we have, 60 degrees out of 360, times the area of the circle, which is pi r squared. And the radius is from the center to M. M is said to be the midpoint. So that means that the radius is 5. So we have 60 over 360 times pi 5 squared comes out to 13.09. Then you take the triangle minus this white area of the sector, and that will give you the shaded area. So you get 43.3 minus 13.09 equals 30.2. That's your answer for that. Moving on to number 22. Again, sorry that it's a little blurry here. We have 16.2 centimeters for this rectangular prism here. The width is 5.5 and the height is 8. And it wants us to find the angle between AB, which is this diagonal all the way through the rectangular cube here, or rectangular prism, and the angle between that diagonal and the base. So that means that we need to make it between the angle and the shadow of that line on the base here. So we don't do it with this line in the front. We do it with kind of like the shadow. If you had a light right on top and shone it down through, this would be the shadow along the base, which is also the diagonal of the base. So that's the angle we're finding. So we need to find this diagonal. Remember, the base is a cuboid, so this is 90 degrees here. So we can use the Pythagorean theorem to find this AC. That actually didn't give us C, so I put in C. We already have AB, so I just labeled it C, or just gave it a different point there. And so this AC is A squared plus B squared equals C squared, Pythagorean theorem. Square root to find the AC is 17.1. Now that we have two sides, 8 and 17.1, we can use SOHCAHTOA, and your TOA, tangent, is opposite over adjacent. So here's tan theta equals the opposite 8 over the adjacent 17.1. Inverse tangent to both sides. Again, make sure your calculator is in degree mode. I think usually with IGCSE, most of the time they work with degrees. When you get up into the A level, you need to pay more attention to whether you're radians or degrees. So the inverse tangent is 25.07. With degrees, you go to 1 decimal point, so that 7 rounds that up to 25.1 degree. Now it asks to write 56 as a product of prime factors. Factors is dividing. So we want to divide this so that we have all prime numbers. So I just start with the easiest one. It's obviously ends in an even number, so it's divisible by 2. So 2 times 28. So I do a little factor tree here. There's different ways of doing factor trees, however you learned it. So divide by 2 is 28, divide by 2 is again 14, divide by 2 again 7. All of these on the outside here are all prime factors, and it wants it to write as a product. So 2 times 2 times 2 times 7, and there's 3 2's, so that makes 2 cubed times 7. Doesn't matter whether you write them all out or in exponent form, either way is fine. 2 cubed times 7. Then going to lowest common multiple, you still need to do a factor tree so you know what the factors are. So the factors of 42 are 2 times 21, which is 3 times 7. These are the factors of 42. These are the factors we already did of 56, so we don't have to do it again. And when we look at this up here with this down here, to get the lowest common multiple, we need every factor and we need the most of every factor. So here's a 2 and here's a 2. This only has 1. This one has 3. We need to take the most, so we take the 2 cubed. Here's a 3. This one doesn't have a 3, so we need to take a 3. They both have a 7, but there's only one of them, so we take 1 7. That's the most of from either side. And we multiply all those together, and that will give you your lowest common multiple. If you multiply 56 out and 42 out, both of them will come into 168, divide into or multiply into 168. So 168 is your answer for that. Now we get to this cumulative frequency graph, and it's already drawn for you. You don't have to draw it. There are 80 total students. Make sure you just check with the top of your graph. Usually in IGCSE, the top of their graph is also the top of the scale here on the side. When you get up into A level, sometimes this scale goes up goes up higher. You might see like a 100 up here. But make sure you double check with the question and with the height of the graph to know what your high number is. It's actually 80, even if the y-axis goes up here to 100 or above. You know, you need to make sure you know the top of your graph. So it's 80 students. And then we get down to the questions here. Use the cumulative frequency diagram to find an estimate of the median. Well, median is middle, which means it's the 50th percentile. So 50% of 80 is 40. So here's the median. I highly recommend you take a straight edge, put it right on that line and draw it to the graph. Then turn your straight edge perpendicular and draw straight down. And when you count this between 20 and 30, you're halfway. So that's 25 should be your answer. I don't like looking at students' work where they have not drawn any lines. It doesn't give you very accurate measurements. Want to make sure that you're doing this correctly. So use those straight edge, draw your lines. Interquartile range, quartile 3 minus quartile 1. Quartile 3 is, of course, 75%. Quartile 1 is 25%. So 75% of 80 is 60. 25% of 80 is 20. So 1/4 of 80 is 20, or 3/4 of 80 is 60. So draw those, use your straight edge, draw the line over to the graph for both your 60 and 20, and then go perpendicular and draw them straight down. So here you get to 28 and 16. So the interquartile range is the part that's between these quartiles. 28 minus 16 gives you 12. There's your interquartile range. Then they ask another question. The number of students who spend more than 40 minutes completing their homework. So now notice minutes is on the bottom. So instead of going from the y-axis to the x-axis, now we're going from the x-axis up to the y-axis. So it said more than 40. More than 40 is this outside part. So we start at 40, use your straight edge, draw up to the graph. Now go horizontally again, perpendicular horizontally, and draw along the line here, and you get 75. But notice that is not your answer. We want more than 40. More than 40 is to the right. So when we come up and then go horizontal, we want this part up here. If it said less than 40, that would be this side of the line. So as you go up and over, that would be your 75 would be less than 40. We want the more than 40, which is this side of the line. So we want 80 minus 75 because it says more than. And so 80 minus 75 is 5. 5 students spent more than 40 minutes completing their homework. And since this is an hour-and-a-half long test, hopefully you spent more than 40 minutes doing this test. Here's our last question on this test, number 25. It's dealing with functions. So here's a function, f of x equals x cubed, g of x equals 5x plus 2. Letter I is a composite function, g of f of x. So that means we need to take f of x and put it into g of x. You work from the inside out. So they're not giving us a number to work with, so you just work with the variable itself. So x cubed is the f of x, and we want to plug it into the x of our g of x. So notice this is our g of x function, and we replace the x with our f of x. So that is replacing the x. So the x becomes x cubed. So now we have 5x cubed plus 2. It's already simplified there. This is inverse function notation. We want to find the inverse function of g of x. So in case you're not familiar with inverse function, you have 2 rules. Switch your x and y and then solve for y. That's how you find the inverse function. So we're taking our g of x, and instead of writing it in function notation, I'm writing it with the y. Remember, all functions are equations, so I can write it y equals 5x plus 2. So the first step is to switch your x and your y. So switch them, put the x over here and the y over here. And then the second part is to then solve for y, or make y the subject. So we subtract 2 from both sides, then divide by 5, and so y equals x minus 2 over 5. They've already written the inverse function notation for you, but as again you move up into A level, you're going to want to do that yourself. You want to show that your equation here is identified as the inverse function of g of x. Then we move down here. They give us a function equation, h of x, which is not given up here, so this is a different function, equals ax squared plus 1. So this is a function they provide for us. And then here's our function equation. When you evaluate h for -2, that result equals 21. So here's our function equation. So we take our -2 and we plug it in for the x, and we plug it in here. So we have a times -2 squared plus 1. So -2 squared is 4, so we get 4a. And this equation is equal to 21, so we subtract 1 from both sides, and 21 minus 1 is now 20. Divide by 4, so a is 5, and we can find our value of a by using this function equation and plugging it, evaluating it into the function they provided. So that's functions there, and that's the end of the test. We have finished paper 2 of W 2018, Winter 2018, or the October-November series, paper 2 from Zone 2. So I've done already for you 42 and now 22, both papers. Paper 2, by the way, is your short answer. Paper 4 is the structured, and paper 2 and 4 are both for the extended content for the IGCSE. Thank you for joining me, and hope to see you again next time for Quick Fix for IGCSE, or for the Zoom room for my A-level series. And again, thank you, and hope it helped.